Hey guys, welcome to review day 2 for our Unit 2 test. Today's review is going to be focusing on finding some components of a graph, particularly the graph of a quadratic function, as well as transformations of various parent functions. Okay, so the first thing we are going to do is this problem right here where we have to find the vertex, intercepts, and different forms of a quadratic. So the vertex of a parabola is going to be the pointy part of your graph, right? So in this parabola, it's your lowest point. If you had an upside down parabola, if it was like this, then it would be the highest point, right? So that point right there is going to be at 3, -1, okay, because it's right 3, down 1, so that's what we'll write. Okay. For x-intercepts, we have the points where the graph touches the horizontal axis right here, right? So that's going to be these 2 points. And if we look closely, we can see that this one is at 2, 0, and this one is at 4, 0, right? Because this is at the second box, this is at the fourth, and x-intercepts are always going to have a 0 in the y value. So 2, 0, and 4, 0. All right, on to the y-intercept. Now, y-intercept is the location on the graph where we touch the y-axis, and that's the vertical one. So that happens right up here at the 8, so this point is going to be 0, 8. All right, so now that we found all the pieces of the graph, we're going to go ahead and rewrite the equation in graphing form and in factored form. Now here's the thing about this. I wrote that you can use any method of your choice, and that's because there's a shortcut method and then there's also a longer method. Okay, so I will go ahead and go over both of those. The shortcut method is that since you have the vertex already, okay, it's very, very fast to just make the equation based on the vertex because, as we know, graphing form is also known as vertex form, and the vertex is very quickly seen from graphing form. So we know that it's always opposite of h, comma, k. And so from this vertex, we know that h is going to be -3 and k is going to be -1. Okay, and h is -3 because you always got to take the opposite sign of the x value. All right, so we also know that the general form of a quadratic equation in graphing form is this: y equals a times x minus h squared plus k. So when we fill in our information, we know that it will be... Also, we don't have to worry about the a because we can assume that it's just going to be 1 in this case. But we'll have x minus 3 because our h is -3 squared, and then k is -1, so -1. And that is the quick way to find this equation. Now, if you don't remember how to do that, or if you don't like that, or it doesn't make sense, you can always, of course, fall back on completing the square. Okay, that is the original way that we learned to convert a quadratic equation in standard form to graphing or vertex form. All right, so the way you do that is you use the box. This is the one that's just the box, not the box and diamond. All right, so you still put the first term of your equation in the top left box. I'm going to go ahead and rewrite the equation down here so we can look at it. All right, so we have our first term up here. The next thing we want to do is go ahead and split the middle term. Okay, this is where we take this term right here and divide it by 2. And the reason we do this is essentially to evenly split this term up between these 2 boxes. So this will give us -3x, and so that's what we'll put in our boxes. All right, now that that part is over, we can go ahead and fill out the outside of the box. So for here and here, we'll go x and x, because that's how we would get the x squared. And then to get the negative 3x's, we need a negative 3. All right, once you fill out the outside, you can multiply those two numbers to get this box, and that's going to give you a 9. Now we're almost done. At this point, we know that our answer, or our equation, is going to start like this. And we know that it's x minus 3 because that's what's on the outside of the box. However, there's always a number out here, and the way you want to get that number is by taking a look at what's in your fourth box and taking a look at what's in your equation, the third number of your equation. We need to have 8, but we have 9. Okay, so to get from 9 to 8, we have to subtract 1, and so that's what I will put in my equation. All right, and that is the longer way to find the graphing form of a quadratic. All right, I guess I'll write that here. Okay, now, next we have to write this in factored form, and again we have a shortcut and then we have the long way. So the shortcut for factored form is based on the x-intercepts of our graph. If our x-intercepts are 2, 0, and 4, 0, right, that means that our factored form is going to be y equals, and it's always going to be just like the opposite signs of what these numbers are. So this positive 2 is going to tell me that I'm going to have an x minus 2. This positive 4 is going to tell me I have an x minus 4. And that's it. You're done. And the reason this works is because you can actually use factored form equation to find x-intercepts instantly. And so we're just working backwards from there. All right. But again, that is the short way. The longer way would be to factor this in the traditional method that we know, using the box and diamond. So we will get our box going. Now, when we're doing box and diamond, we still put the, we still put the first term in the top left box, but this time we also have to put the third term, that 8, in the bottom right. All right, and now we're ready to do the diamond. Now for the diamond, we have to, and I'm going to rewrite my equation here. For the diamond, we have to multiply the first and the third terms together. So this one and this one to get the top. So 8 times x squared goes up here, which is 8x squared. And the bottom is going to be negative 6x, which is that middle term. All right, and this is where you ask yourself, okay, what two numbers multiply to make 8x squared and also add to make negative 6x, okay? And eventually you would hopefully realize that if you did negative 4 and negative 2, you can check that, right? You could say, okay, well, negative 4 times negative 2 equals 8. We're good to go. And then you could check the other piece and say, okay, well, does negative 4 plus negative 2 equal 6? Or negative 6? Let's try that again. And it does. So at that point, you're like, okay, this works. And we can fill in our remaining boxes. Okay, once we've done that, we can go ahead and do the outside of the box. So we have x and x to make x squared, negative 4 to make 4x, negative 2 to make negative 2x. And sure enough, you find that your factored form is x minus 2 times x minus 4, which is exactly what we got with the shortcut. Okay, so again, it's up to you which method you prefer. We've learned both, but I wanted to make sure you're comfortable with each of them. All right, so now on to the transformations piece of this. if I give you a function here, the first thing you want to do is decide which parent function it's going off of, and this is coming from a rational function, and that should be pretty obvious if this is the one you're looking at, because there's only one type we worked with that involves a fraction, right? And so since it's a rational function, you know that the general format looks like this. So following that, we can talk about the transformations, right? The number on the top is the a value, so we know that it's going to have a vertical stretch. It's a stretch because it's a number bigger than 1. So vertical stretch by a factor of 3. That's what this 3 is going to do for us. It's our a. We can see that this plus 2 down here, that gives us an h. That means we're going to move to the left by 2. Because h is always opposite, remember that. Okay, and lastly we have this plus 8, actually maybe not lastly, but next. And that's going to be our k, so we're moving up 8. And now the last thing is that we actually have a negative sign up there. So we have a reflection about the x-axis. Okay, and that is all of the transformations that are happening here. All right, number 2, we want to write the equation based on the descriptions that they've given us. So first of all, they've given us a square root function. So let's go ahead and write the general form of the square root function. It's going to be y equals a times the square root. Remember that the general format of these functions just changes based on like this house for the most part. Okay, so if it opens downward, that tells me that I'm going to have a negative sign in the beginning of my equation. If it's been vertically stretched by a factor of 6, that tells me my a value is 6. And the locator point of 6, 3, this is my opposite h, k. All right, so my h is going to be negative 6, because we always take the opposite of the x value, and my k is going to be 3. Because we always take the y value as it is. All right, so now we're ready to write our equation. We have a negative sign up front. Our a value is 6. We're just following this and filling in the pieces. Times the square root of x. Our h is negative 6, so we're going to do a minus 6. And then k is positive 3, so we'll do a plus 3. And then you're done. All right, the last problem is to write an equation for this graph. Now remember, if you're writing an equation from a graph, you have to think about how that graph changed from the original version. Now, if it's a V-shaped graph, this means it's an absolute value function. You got to note that so you know which general format to go off of. It's going to look like this. All right, and then you got to think about how it transformed. So we can tell that it moved to the right by 1, right? From black to blue, we moved right 1. And that gives us an h value of negative 1, because h is always opposite. We can also see that we moved down by 2. It's kind of ugly. Down by 2, and down, up and down is our k, and k is going to be negative 2. And lastly, hopefully you would also be able to tell that this graph was flipped over. So we will say that there was a reflection. And that'll give us a negative sign in the beginning of our equation. So we're ready to write the equation. Just fill in those pieces. Don't worry about a when I'm giving you a graph to go off of. It's just going to be, the stretch factor is just going to be 1, so we can ignore it. So we have x and then h. Oop. H is negative 1 and k is negative 2. And lastly, we have a negative sign up front to flip our graph. Okay, and that is all.